Okay, this is the airplane one. My picture did not turn out that good. So it looks like, it's like that. I had to draw my own picture. Yeah, it's an airplane, whatever. Some crazy thing flying. It like drops a cargo, and like this is the island, I guess, whatever. And the package, we're trying to find out. We're trying to find the combination velocity. We're trying to find that velocity when we combine them together. We're trying to find. Yeah, I wish there wasn't a box here. I would have drawn the picture better. We're trying to find that, and then we're trying to find the impact angle. All right, first we're going to do is fill out the chart. You guys are amazing. Here we go. Complete the chart, answer the question. All right, first thing you do, big goose egg here, 0, and then negative 9.8 meters per second squared. And the airplane is flying at an altitude of 1,500 meters above the island. That's the dy. That's actually negative because we're going down. The package is going down. So 1,050 meters. What else do we know? In the y-axis, the initial is 0 there. Do you know anything else? Oh, yeah. He's flying 115 meters per second. I don't know if that's actually real or not. That's probably, I don't know. Airplanes go pretty fast. Gotta look up some more realistic. Tune in like 30 years. Maybe I'll have better problems. I don't know. Actually, I got this one online, so maybe it's true. All right, what are you going to do? They want to know how far back the airplane should release its cargo. First thing I'm going to do, y-axis. Solve for V final. I'm not going to use any of the equations. Oh, Miss Naylor, you didn't give us the equations? Yeah, you have to use a reference table. So you get your handy-dandy reference table out. Right here. Pick one of these. Time, no time. That's one we want. V final squared equals V initial squared plus 2AD. That's 0. So now I can write V final squared equals 2 times negative 9.8 times negative 1050. Put that in your calculator. V final squared equals 2, 2 times 9.8 times 1050. I left everything positive because multiplying by that. 2580. Square root both sides. V final equals with the square root. So I'll take that number. I hit second. I just hit second. So I hit second. Square root, second. Answer key. So it gets me the answer for the previous number. V final is 143.45. So that's what this says. That is 143. I'll just do 5 right there. Meters per second. So meters per second. Now, what other thing do I need? I gotta have negative. I choose the negative because we're going down. Goose egg down, because this goes out positive or negative, right? And I'm going to choose the negative. Square root, positive, negative. I'm going to choose 143.4. Sometimes you don't like to keep the 5, whatever. Now I got to do time. Find time. Still on the y-axis here. I'm going to find time. I'm going to use an equation for time. You can, maybe I'll spice things up. We'll do D equals 1/2 AT squared. I can use the other one. I like this one too. V initial plus AD plus AT. This is 0. That one's easier to use, but whatever. I want to do this one. D would be negative 1050 equals 1/2 times 9.8 negative times my T squared. So I'll go 1050.5. That's the half. 0.5 times negative 9.8 be negative 49 T squared. Divide by negative 0.49 both sides. Negative 4.9 both sides. And the two negatives make a positive. So I'm over there. 10, 5, 0. Sorry, 1050. And then divide by 9.8. And then I have to square it because that's 1074 equals t squared. Square both sides. Oh, much longer this way. I gotta do it, but whatever. T equals square root the previous answer. Oof. Darn it. What is the answer? Good, that's the number still in there. I just checked. Now I hit second square root, second answer. Good. 10.35 seconds. Ugh, I hate it when it's the fives because if you want to be accurate, you got to keep the 5. It's going to really matter for package. Yeah, I'm going to do that. I'm going to keep, so it's going to be up here, 10.35 seconds. I wonder what the other number shows up as. Oh, man. I just did my corrections. Somehow, when I plugged that into the calculator, I got a wrong number. That's not right. So I'm just going to show you again. I don't know what happened. 1050, I have to go back and watch the video, divided by 9.8 is that number, and then I got to square root it. What? Oh, jeepers creepers. Oh, man, you're going to have to totally ignore that. It's not 9.8. It's 4.9. Oof, goodness. So 1050 divided by, because the 1/2 times the 9.8 divided by 4.9. Now, square root that answer. 14.6. Dang it. 14.6. Ooh, I'm so glad I did this both ways. Oh my goodness. 14.6. 64. I don't know. I want to do 4 there. 14.64. Oof. How did I know? Because when I did it the other way, I didn't get time the same. I was like, what the heck? Just time the other way. I did V final plus AT. So I don't do this way because, ugh. So V final is, the previous number, 143. And then I had AT, and that's divided by 9.8. So the T the other way was 143 divided by 9.6, 0.45, 0.45 divided by 9.8, 14.6. All right, so both ways should produce a T that's correct. 14.6. I would change this, but I was just tired of doing these. Now I can do, do I want to leave that many decimals? Because I'm trying to be really accurate. So maybe I went around to the hundreds place. So I'm going to 4 or less, drop that mess. So it's, but the 7 is more, 5 or more up the score. So I'm just going to go 64. All right, and that's seconds. Now I got a G. Now I'm looking the x-axis. I go D equals V initial T. I gotta pick one. I'll pick this long one right here, but then this part goes to 0, so I'm just left with this section. And I know my T, I know my V, my D range part. That's what I'm looking for here in my DX. It's 115 times 14.64. Like that number. And I'm just gonna multiply right now. 115. My distance is 1,683. Oh, we'll just 2 meters right there. That's pretty far, right? He's pretty high up there. He's going to be like, it's almost like a mile. It's pretty far. It's not filling this thing. 1,683. The velocity never changes in the. Oh, I gotta put this little. Same arrow. So my little airplane guy. Same arrow. That speed is always 1115. 1115 meters per second. 1115 meters per second. Blah. 115 meters per second. Whew. Now we're going to do this bit. That information. So here's the, the arrows. All right. I got to find that arrow. What's the resultant arrow? So I bring how do I know how to draw that? I take that, I slide it over. This was 115 meters per second. This one was 143, 140. It's going down, but 45 meters per second. Be the negative. I'm trying to find C. E squared plus B squared equals C squared. So I'm going to do 115, there your A, that's squaring, plus, there's your B, 140. You negative, you square it, becomes positive. Put that in. 115, square it. 115 square it, plus 143.45 and square it's right there. Get that number. Ooh, that's a huge number. 338,029 equals C squared. Square root both sides. That's a meters. In here is a meter squared second squared. Comes out perfectly. I have to square root it. Second, square root, second, answer key. My C, that velocity right here. My C is 183. Where do I want to round? I want to round to the 9. 5 or more up to score. So I'm going to do 9 place. That's a single meter per second. So right here, that speed is 183.9 meters per second. That is the resultant combined velocity. Sometimes they call that speed because you're doing an X and a Y. Right, now we're gonna find that impact angle. Hopefully we were doing that before. You gotta choose the opposite. It's opposite over adjacent, opposite over adjacent. 143.45, that's that velocity divided by the adjacent length. There's meters per second here, meters per second here, they cancel out. Inverse tan of that stuff. Down. So I go inverse tan. So second, that key, now I put 143.45 divided by 115. Theta equals 51.3 degrees. Ooh, there you go.